In our lesson today, we're going to learn about compound interest. We learned about simple interest last time, and simple interest is calculated only on the principal amount. Okay, remember that the principal is the original amount that you deposit or borrow from a bank. All right, simple interest is calculated on the principal only. Compound interest is calculated on the balance. Okay, and this is how most accounts at a bank will work. They'll calculate the interest based on the amount that you have in your account, the balance, rather than just on the principal amount. Okay, so we're going to take a look at compound interest today and see how it differs from simple interest. Okay, when you first make a deposit, no interest is earned. The balance is equal to the principal. Okay, so the first time that you go into the bank and you open your account, you put your money in the bank, your balance is the principal amount. No time has gone by yet. Okay, what we're going to do is see what happens to the account balance after 1 year, 2 years, and 3 years. And we're going to use an interest rate of 2% on this loan or on this account. Okay, now after 0 years, so at the very beginning, the principal and balance are equal to each other. After 1 year, in this example, all right, after 1 year, compound interest and simple interest are equivalent. They're the exact same thing, the same amount. Okay, so you calculate the amount of interest for the first year based on the principal amount. Principal times rate times time. Okay, so the principal in this case, we started with $100. Our rate is 2%, and this is only for 1 year. So to calculate the amount of interest earned, all I'm going to do is 100 times 2%, which is 200ths times 1, and that gives me a value of 2. Okay, so I can see here after year 1, I have the $100 that I started with, and my compound interest, I've earned an extra $2. Okay, so to get the balance after the first year, the balance is going to equal my starting balance of $100 plus the $2 that I've earned in interest, making my account balance after 1 year $102. Okay, so I started with $100. I'm up to $102 now because I've earned $2 in interest. Okay, let's see what happens in our second year. So here we are at year number 2. Okay, after the second year, compound interest is calculated on the balance in the account, which is the principal plus the first year's interest. Okay, so remember, we're going to take the balance from the first year, which right up here we said was $102. Okay, to calculate what the amount of interest earned would be, okay, I'm going to do my 2% rate, 2% times the $100 plus the $2 that I had from last time, which is $102. All right, so my previous balance of $102 times 2%, all right, that gives me a new interest amount of $2.04. Okay, so if I look and see what's happening over time, at the beginning I started with $100. After 1 year, I had $100 plus $2 in interest, so my amount was $102. And now after 2 years, again, I have the original 100 that I started with, plus the $2 in interest that I earned the first year, plus now another $2.04 that I've earned in interest from the second year. So now my new balance is going to equal my previous balance, which was $102, plus the new amount of interest that I've earned, $2.04, making it $104.04. Okay, my account balance after 2 years now is $104.04. So let's see what happens now after the third year. Okay, after the third year, the compound interest is calculated on the balance in the account, which is the principal plus the first and second year's interest. Okay, so for at the very beginning, I had $100. That's what I started with. After 1 year, I had $100 plus the $2 in interest, which gave me $102. After 2 years, I had $102 plus the new amount of interest of $202.04, which now gets me to $104.04. And now to calculate the new amount of interest for the third year, again, I'm going to take my previous balance, which was 104.04, and I'm going to find 2% of that. Okay, so if I punch into my calculator, all right, get rid of that number, 200ths, which is 2%, times 104 and 4 cents. And notice that I get this number here, 2 and 0808. I would have to round this number so that it's money. Okay, so it looks like $2.08. That zero right there isn't enough to round us up. So here, the amount of interest that I've earned on the third year is about $2.08. Okay, so now to get my balance, well, again, I'm going to take my previous balance, which was right here, $104.04. I'm going to add on the new interest. I'm going to add on that new $2.08. And so I'm going to have a balance of $106.12 after 3 years. Okay, so notice that the amount of interest grows each year because the amount in the account, the balance grows after each year. Okay, if it was just simple interest, all right, that's only calculated on the principal. I would only earn $2 every year. But because my balance, my interest gets added and my balance changes, the amount of interest changes each year as the account balance grows higher. Okay, so this is one of the benefits of compound interest, where the amount of interest is calculated off the total balance and not just the principal amount. Example number 1, suppose you deposit $200 in a savings account that earns an annual interest rate of 1% compounded annually. Okay, when they say compounded annually, that means that the interest gets added in once a year. What is the final balance in your account after 4 years? Round to the nearest cent. Okay, so we have our table here, we have our time in years, we have our compound interest amount, and we have our final balance. We're going to fill in each of these until we can determine what that final balance is at the end of year 4. Okay, year 0, this is the very beginning when you open up your account. Okay, since it's at the beginning, you haven't earned any compound interest yet, so that's going to be $0. And your balance is what you have started with, which is right here, $200. Okay, so very simple at the beginning, it's just what you've deposited, $200. All right, after 1 year, in order to calculate the amount of interest earned, we're going to take our previous balance, which in this case was $200, and we're going to multiply it by the rate for each year, which was 1%. 1% in decimal form is 100th. Okay, and if you did 200 times 100th, notice that you get an answer of 2. Okay, so we will have earned $2 in interest in 1 year. And now to get the final balance, we take the previous balance, which was $200, add in the interest that we've earned, which is $2, and our balance after year number 1 is $202. Okay, this would be the same as the simple interest after 1 year. Our account balance would be $202. Now in year 2, this is where it differs from the simple interest. To figure out the compound interest, we take the previous balance, which was $202, and again, you multiply it by the rate, which was 1%. And if you do 202 this time, times 100th, notice that our interest isn't $2 anymore, it's $2.02. All right, so we've earned $2.02 in interest after the second year. And now to get our balance after the second year, we take year 1's balance, which was 202, add in the interest that we've earned, $2.02. And so the balance for year 2 is $204.02. For year 3, to calculate the interest, we're going to take year 2's balance, $204.02, and multiply by the rate of 1%. And if we do 204 and 200ths times 100th, all right, we end up with 2 and 402 10,000ths. But again, we're going to round this so that it's money, 4 cents. That 0 is not enough to round us up. So we're going to say here that this is about, we'll use the approximate symbol here, $2.04. All right, so now we'll take the previous balance, $204.02, add on the interest of $2.04, and that gives us a final balance in year 3 of $206.06. Now we've made it to year number 4. Before we can get the balance, we need to know how much interest we're going to earn in year 4. So we'll take the previous year's balance, $206.06, and multiply that by 100th. And again, we're going to have to do some rounding here. It's not going to be exact. Let's punch this in. $206.06 times 100th, and you get 2 and 606 10,000ths. When we round this, 600ths will not round up because of that zero there, so it's going to be about $2.06. About $2.06 in interest. And now to figure out year 4's balance, we'll take year 3's balance, $206.06, and add on the interest of $2.06, which means in year 4, our final balance is going to be $208.12. That is the account balance at the end of year number 4. In example 3, they want us to make a table and find the balance after 2 years. Okay, so it's going to be similar to what we did in our last example. We're starting with a principal amount of $500 at an annual interest rate of 3%. And again, we're going to compound our interest annually, meaning once per year. Okay, so why don't we make our chart? We're going to have the number of years, and we're going to have the compound interest, and then we're going to have the final balance. Okay, so here's our little table, and we're going to start at the very beginning, which is 0 years. We will not have earned any compound interest yet, and our balance is our principal amount, which is $500. Okay, after 1 year, to calculate the compound interest, we're going to take our balance of $500 and multiply by our rate. 3% is the same as 300ths. And if we multiply 500 by 300ths, 500 times 300ths, we get an answer of 15. So we will have earned $15 in interest during the first year. And now to get the balance, we'll take the old balance, $500, and add in the interest of $15, making our final balance for year 1, $515. Okay, we need the balance after 2 years, so let's do this again. To calculate the interest now for 2 years, we're going to take year 1's balance, $515, and multiply that by 300ths. Okay, and when we do that, $515 times 300ths, we should end up with $15.45 in interest. Okay, to get the balance now, we're going to take year 1's balance, $515, and add in the interest of $15.45, meaning that at the end of year 2, the final balance is going to be $530.45. So in our previous examples, we made a table to figure out the compound interest earned and the account balance. And this is easy to do if it's just for a small number of years, like 2 years, 3 years, 4 years, etc. Okay, but what if the number of years becomes very large, right? Rather than making a table, all right, we can just simply use the compound interest formula. Okay, this is the compound interest formula when you compound your interest 1 time a year. B equals P times, in parentheses, 1 plus R raised to the nth power. B represents your final balance. P is the principal amount that you've started with. R is your annual interest rate in decimal form. And N, the exponent, is the number of years. Okay, let's use this equation in our example number 3. Okay, it says when Ed was born, his aunt opened a money market account for him with $1,000. The annual interest rate is 5% compounded annually, so once a year. Calculate how much money Ed would have after 10 years, 20 years, and 30 years. Okay, so I'm going to start by dividing my work area into 3 parts here, so I can do each of these examples. And I'll start by writing the equation in each spot there. B, the balance, equals P, the principal, times 1 plus R, the rate, raised to the n power. And again, and one more time. B equals P times 1 plus R raised to the nth power. All right, so in each of these examples, we want to know how much money Ed would have. So what's the balance after each one of these examples? So we're going to start each of these with B equals, and the principal amount that Ed started with was $1,000. So we're going to fill that in the equation for each spot for the principal. And now the interest rate is 5%. 5% as a decimal, remember, is 5/100ths. So in the parentheses for each of these, we're going to have 1 plus 5/100ths, 1 plus 5/100ths, 1 plus 5/100ths. Okay, so all of the equations look the same right now. The only thing that's going to be different for these is n, which remember is your number of years. We're going to do this for 10 years, 20 years, and 30 years. So we'll make the exponent 10, 20, and 30 for the last example. Okay, in order to calculate the value of B, we're going to follow the order of operations. Okay, in each one of these examples, we have to do what's in the parentheses first, 1 plus 5/100ths. Well, 1 plus 5/100ths is just 1 and 5/100ths. So we're going to have B equals 1,000 times 1 and 5/100ths to the 10th. B equals 1,000 times 1 and 5/100ths to the 20th. And B equals 1,000 times 1 and 5/100ths to the 30th power. Okay, next thing that we have to do is evaluate the exponent. So we're first going to do 1 and 5/100ths raised to the 10th power. If we punch that into our calculator, all right, 1 and 5/100ths raised to the 10th, I'm going to use that caret symbol, raised to the 10th power, and I get this decimal. I'm going to write out the whole thing. Okay, so I'm going to have B equals 1,000 times 1 and 6,288,94627. To get B, the account balance now, I'm just going to take that number and I'm going to multiply it by 1,000, which is going to be 1,628 and 8,94627. When you multiply by 1,000, this decimal point moves to the right 3 times. Okay, so here's our account balance. We're going to have to take this number and round it. After 10 years, Ed's going to have approximately $1,628.89. Okay, for 20 years, I'm going to do 1 and 5/100ths to the 20th power. So let's punch that into our calculator. 1 and 5/100ths raised to the 20th power. And there's our decimal this time. Again, we're going to write out the whole thing. So B will equal 1,000 times 2 and 653,297,705. Now we'll multiply this number by 1,000. 2,653 and 297,705. And now to get the balance, we'll round it. It's approximately $2,653, and that 7 will round us up from 29 cents to 30 cents. All right. Finally, after 30 years, okay, B equals 1,000 times. We have to do 1 and 5/100ths to the 30th power. 1 and 5/100ths raised to the 30th power equals 4 and 321,942,375. Multiply that number now by 1,000. 4,321 and 942,375, which means after 30 years, Ed's going to have approximately $4,321.94. Okay, so if you know your principal, your rate, and your number of years, you can simply plug those values into this equation to calculate the account balance. In example 4, we're told that a graduate student has kept money in a savings account since middle school. After 12 years earning 4% annual interest compounded once a year, The account balance is $2,560. What was the original deposit rounded to the nearest $10? Okay, so we'll start by using our compound interest formula. B equals P times 1 plus R raised to the nth power. All right, and they want to know what was the original deposit. So we're looking for the principal in this example. So I'm going to put P for the principal. They tell us that the account balance is $2,560. And 1 plus R, our interest rate. Okay, they tell us that the interest rate was 4%. As a decimal, that's 4/100ths. And they said after 12 years, so N, our exponent, is going to be 12. Okay, we're going to use this equation in order to figure out P, the principal. Okay, we'll start out by using order of operations, which means I need to do what's in the parentheses first. So I'm going to have 2,560 equals P times 1 plus 4/100ths is just 1 and 4/100ths raised to the 12th power. Okay, now I'm going to find the value of the exponent. I'm going to do 1 and 4/100ths raised to the 12th power. So I'm going to have 2,560 equals P times, let's punch that in our calculator, 1 and 4/100ths raised to the 12th power. And I'm going to write out that entire decimal. So I'm going to have 1 and 601,032,219. Okay. And in order to get the value of P, the principal, I'm going to have to divide both sides by that number. So I'm going to divide by 1 and 601,032,219. And over here, I'm going to divide by 1 and 601,032,219. And on the left side, I know that those are going to simplify to 1, leaving with P, the principal. And to get this answer on my calculator, all right, I'm not going to erase this number. All right, I'm just going to do 2,560 divided by, I'm going to hit second and then the answer button. And that is the number when I do that division. Okay, so I'm going to have 1,598 and 968,447 is the value of P. Okay, now I need to take this number and round it to the nearest $10. Okay, so it looks like right here that I have $1,590, but that 8 right there is going to round us up. So P is going to be approximately 1,600, which means the original deposit was about $1,600. In our previous examples, we've been using the compound interest formula for when the interest is compounded only one time per year. Oftentimes, interest gets compounded more than once per year. When that happens, okay, our formula is still going to be set up the same way. The only difference is that the values of R and N are going to change, okay? R will represent the interest rate for the interest period, and N will be the number of interest periods. Okay, so let's look at this example in number 5, where we're going to compound our interest more than one time in the year. 5 says, find the total balance owed on a 5-year, $1,000 loan that charges a 6% annual interest rate compounded every 4 months. Okay, so they're going to add the interest in every 4 months. Okay, we're going to find the account balance to the nearest dollar. So let's set up our equation. B, the balance, equals P, the principal, times 1 plus R raised to the nth power. We are finding the total balance, B, and the principal that we've started with is $1,000. Okay, in parentheses, we're going to have 1 plus R. Now, R this time is not going to be the interest rate of 6%. Because we're compounding more than once per year, we have to use this little side equation. To get the value of R, you take the annual interest rate and you divide by the number of interest periods in the year. Okay, so for this example, R is going to equal, all right, the interest rate is 6%, so that's the annual rate, 6/100ths. And we're going to divide it by the number of interest periods in the year. They tell us here that we're going to compound the interest every 4 months, which means that we're going to compound the interest 3 times in the year. Okay, 4 months, there are 12 months in a year. 12 divided by 4 is 3. So R is going to equal 6/100ths divided by 3, which gives us a value of 2/100ths. So that's the value of R that we're going to use in this equation. Okay. To get the value of N, we need to know how many interest periods there are going to be. So for N in this example, well, we just said that we're going to compound it every 4 months, which is 3 times per year. And we're going to do this for 5 years. So 3 times a year for 5 years means that we're going to have 15 interest periods. So our exponent is going to be 15. This is the equation that we're going to solve. So B equals 1,000 times 1 plus 2/100ths is 1 2/100ths raised to the 15th power. All right, now we'll do the exponent. B equals 1,000 times, let's do 1 2/100ths raised to the 15th. And again, we're going to write out that entire decimal. So we're going to have 1 345, 868, 338. And now we'll multiply that number by 1,000. So again, just move that decimal right 3 times. 1,345 and 868,338. And now we'll round this number to the nearest dollar. B is approximately, all right, well, looks like 1,345, but that 8 right there rounds us up to approximately $1,346. Okay, so the total owed will be about $1,346. In example 6, we're going to be using a credit card to purchase a bicycle for $150. The credit card has an annual interest rate of 30% and it's compounded monthly. The interest gets added in every month. If there are no additional late fees, how much would you owe after 1 year of not paying off the balance? Round to the nearest dollar. So we'll start by using our formula. B equals P times 1 plus R to the nth power. Okay, and we're looking for the total balance owed. B equals the principal, the amount that we spent on the bike was $150, times 1 plus, and now we have to calculate the values of R and N, again, because we're compounding our interest more than once per year. Okay, so R equals the annual rate, which was 30%. As a decimal, that's going to be 3/10. And we're going to divide it by the number of times that we're compounding in the year. Since we're compounding monthly, all right, that means we're going to compound the interest 12 times in a year. Okay, if you do 3/10 divided by 12, that gives you 25 thousandths. Okay, 3/10 divided by 12 is 25 thousandths. So that's the value that we're going to put in here for R. Now for N, okay, N is the number of compounding periods. We're going to compound 12 times in a year, and fortunately, we're only doing this for 1 year, which means that N equals 12. B equals then 150 times 1 plus 25 thousandths is 1 25 thousandths raised to the 12th power. Now we need to do 1 25 thousandths to the 12th power, so B equals 150 times, let's do 1 25 thousandths raised to the 12th, and we're going to write out that whole decimal. So 1 344, 888, 828. And now multiply that number by 150 times 150. And again, we'll write out that whole number, 201 and 733, 3236. Okay, so this represents our balance, and we're going to round it to the nearest dollar. B is approximately, well, that 7's enough to round 201 up to 202. Okay, so that means that the balance owed is about $202. Okay, so make sure that you pay attention to the question to see how many times you are compounding the interest. That way you'll know which values you're supposed to plug in for your R and N values.